In this problem, we're asked to factor this polynomial here, and you'll notice that I made this rectangular model down here. If you watch my videos on how to multiply these polynomials, this should make a lot of sense. If you didn't, I would suggest taking a look at those, as what I'm about to do will make a lot more sense if you do. So what we're going to do, you'll notice that there are 4 boxes here, and in our polynomial, we only have 3 terms. So I'm going to go ahead and rewrite this polynomial here with 4 terms, and I have to figure out what those 2 extra terms are going to be. Now, we are going to take the middle term here and break it into those 2 terms. And effectively what we're going to be doing is factoring by grouping, but using this method tends to be a little bit easier. We're going to put the first and last terms in the corner here. And without getting too far into it, one of the things that you can consider is the fact that this term times this term is in fact negative 12x squared. And it kind of makes sense, and just take my word for it, that this cross product here using the other diagonal ends up having to be the same thing, or else it's not really a rectangle. So what we're looking for is 2 terms that combine to equal 1x and that multiply times each other to equal negative 12x squared. Okay, well, the fact that they multiply together to equal negative 12x squared tells me one of them's positive and one of them's negative, which means I'm really subtracting or canceling. And we could do a little guess and check, but I do know that those 2 terms are going to be 3x and 4x. And then I have to determine which one's going to be negative. So I put those terms up here, and since I end up with more positives, that tells me that the smaller of the 2, 3x, has to be the negative. So now I know what to put in my box here. And for completeness sake, I'm going to put that up here as well, so it's real clear what I'm doing. And you can see that these 2 things here are in fact equal. So I can rewrite it with the same value. All right, and now here's the great part about this. And again, this is really, factoring is just the inverse of multiplication. So we're really just working backward here. But what we're looking for is what is the greatest common factor of each row and column. And so I see here I have a 6 and a 4. 2 goes into both of those. And I have an x squared and an x. Well, both of those have at least one x. Then I'm going to do the same thing for the next term. Since it has a lead negative, it's going to be negative. And then 3 and 2, well, those only have a common factor of 1. Now I'm going to do the same thing for the columns. Here I have a 6, and here I have a 3. Well, 3 goes into both of those. I have an x squared and an x. Both of those have at least one x. And here I have the first term here is positive, so I'm going to have a positive factor. And I factor out, well, I have 4 and 2. A 2 goes into both of those, and the second term here has no x's, so I can't factor out any x's. And believe it or not, we have now factored this. And just to verify that, we can verify that 2x times 3x equals this. And we're just using a rectangular model. So if you think of this as the height and the base of this rectangle, this would be the area. 2x times 3x equals 6x squared. And we could do that for the rest of them as well. I'll let you verify those yourself, but it's a great way of double checking. The one I will show you is that we have 3x times negative 1. Well, that's going to be a positive times a negative, so I do get the negative coefficient here. And when I said that we are done, well, I meant it. This is one of our factors. And then this is the other. And we have here that the height times the base equals the area, which we set the area up to be our polynomial here. And that's it. Again, if you look back to my previous videos where I talked about multiplication, we actually started with this, assigned each one of these to either be the height or the base, as you can see here and here, and then we worked backward to create the 4 boxes and then combine like terms to get to our original polynomial. But since we were factoring, this is the direction we were going in, and there is our solution.